Alrighty, so 2.6 is all about um, algebraic limits. In other words, you have a function that has a problem at a limit and at a value of x, and so but through the magic of algebra we can eliminate it. The idea being, most of the time what you have is a hole, and at this hole right here, it's going to be 0 over 0 when you evaluate the function. And so because of that, when I do some elimination, I do some factoring and some canceling, it's going to make it go away. For instance, this function right here comes to mind. And you're like, well, that's cool, Jay. What does it look like? I don't really care. But what if they ask me to take the limit as x approaches -2? Well, on top, it's going to be -2 times 0 over 0, which is 0 over 0, which is undefined. And whenever I see 0 over 0 like this, my first thought is, I need to look and see why that is. And the reason that is because you see we have an x plus 2 on top and on the bottom. Now, it may not be obvious that I have an x plus 2 on the top and the bottom. For instance, in this case. Maybe it's not so obvious. Sometimes I'm going to have to factor. But once it's in this factored form, I can cancel them off. And now, because of the magic of algebra, now I can say, hey, look, what is that? The limit as x approaches -2 of x. It's just -2. Now, of course, you can always look at the graphs of these, but we want to practice doing it with the algebra because that's going to help us out later on when we get into some other things down the road. So again, here's x plus 2x or something, I think I said, divided by x plus 2. And you're like, look at this, it's a line. This line looks just like x. I agree with you. And so if you trace along this line, why isn't it giving me the thing? If I trace along this line, you can see at any value of x, there's a y. Until you get to here. Ah, it's a hole. And yet it's clear to anybody that as you come toward x equals -2 right here, as you come toward it from either direction, it sure looks like the y value should be -2. And that is what we get when we simplify the problem. Now, another one might be kind of a gross one. I'm going to kind of go big here. It's not big, but it's kind of big. I'm just going to do this over... The limit is x equals -5, approaches -5. Well, if you plug that in, you're going to get 25 minus 30 plus 5 over 25 minus 25, which is 0 over 0. So help me God, if you put 1 or you leave it as 0 over 0 or something like that on the test, I will go bananas. It's kind of a big freaking deal. The fact that there's a 0 over 0 when you put in x equal -5 means that there is an x plus 5 on the top and the bottom. That's the only way that can happen. Because you are taking this thing right here, which is, when you plug -5 into it, becomes 0, times some other garbage. And as you well know, Mrs. So-and-so in the 3rd grade said 0 times anything is 0. Except infinity, don't say that. But other than that, yeah. And so all I have to do is, well, factor. And so you're like, but I don't know what goes into these guys. I always sucked at factoring. Okay, I can help. So we know it's going to be x and x, because x times x is x squared. Now, we just said x plus 5 has to be up there. Has to be, because that's how I got a 0, because I put -5 plus 5 was 0. Well, that only leaves one thing. What times what is 5? 1 times 5. Furthermore, notice that it is a positive 5, meaning that they both have to be both positives or both negatives. But since this one's already positive, that one has to be positive as well. So x squared plus 5x plus 1x plus 6x plus 5. Ta-da! On the bottom, we again know there has to be an x plus 5, and then you're like, oh, that's a difference of squares. Cool. There you go. Whoosh, whoosh. And so now I can take the limit as x approaches negative 5 of x plus 1 over x minus 5, which will be negative 4 over negative 10, which should be 0.4. So let's go look and see what's up. Now, again, x squared plus 6x plus 5 divide by x squared minus 25. Ta-da. And I said what happens as x approaches negative 5. Dude, check it out. Coming down toward 0.4, coming up toward 0.4. Sure looks like that should be 0.4. It is. Now, you're like, well, when you factored it, Jay, what were you left with? Well, you're left with x plus 1 over x minus 5. Oh! They're the same. Not so fast, Haas. They're the same everywhere except at negative 5. Check it out. The purple one. Oops. The purple one exists there. That's because I eliminated the hole. It's gone. I filled it in, if you will, okay, by this cancellation process. Okay, it's pretty easy to do. You really not too bad until you run into one of these things in a dark alley, and then you really start to kind of question your sanity a little bit. So if you had, come on. I just saw it. Where did it go? I need to put my glasses on. Well, we'll do this one first. The limit as x approaches 0 of 1 plus x minus 1 minus x over x. Oh dear. When you plug the 0 in, you're going to get 1 plus 0, which is 1, so 1. 1 minus 0, which is 1. 1 minus 1 is 0 over 0. Oh, geez, it's a problem. But this guy does not factor in the same fashion that the other one did. The other one factored nicely. You could factor a piece out of it. This one, not so much. I'm just going to move it over here so it's a little more conducive to the next step. Whenever you see a square root in a limit situation, and you would like to make it so, because I don't want 0 over 0, what you want to do is multiply by the conjugate. I read a deal a couple years ago, an article about how we as mathematicians, we microaggress people. We say things like, here's the trick. But here's the deal. I'm inside the club, and I'm letting you in on the secret handshakes. That's what I'm doing here. This is a trick. It's literally all it is some algebra trick. Someone who is way more clever than I came up with this idea. And remember, anything divided by itself is 1. So I'm just multiplying by this thing right here. Is just a fancy way of saying 1. So I'm not changing a value. When I multiply by, remember I'm doing a plus b times a minus b. It's going to be a squared minus b squared when you FOIL it out. So it's going to be 1 plus x minus 1 minus x. Okay, the radicals go away. On the bottom, and here's a trick that a lot of people screw up because, whatever, they think they're going to get ahead of the game and clean stuff up. This is a place where it doesn't really pay to clean up too much. You want to leave it like this. There's a reason for this, and you'll see in a moment. Just leave that alone. So on top, you're going to get 1 plus x minus 1 plus x over x, 1 plus x, 1 minus x. Okay? So you're left with, on top, you're left with 2x. Well, wait a minute. There's a 2x on the top and a 1x on the bottom. They cancel off. And now I'm left with 2 over 1 plus x plus 1 minus x. Now remember, that's not the final product, friends. What I want to do is take the limit of this guy as x approaches 0. Was that on top is 2. So that's good. I got rid of the issue that I had a minute ago, which was 0 on top. Oh, I got rid of the problem on the bottom too, because now it's going to be the square root of 1, which is 1, plus 1. So it's 2 over 2. That means the limit is 1. And we'll go see if that looks right to us. I think it was that. Divide by x. Just double check that I did that right. I think I did. And the question is, what happens here at 0? Well, first of all, it's clearly undefined. But it sure looks like the y value is approaching 1 as you approach 0. So yay! Okay. So again, conjugate, that's a big one. Okay. Another one that comes to mind is this guy, and I'm going to pause you for just a minute so that I work it. I can't find the one in the book that I want to show, so I'm going to make one up myself. So one moment, please. All right, here we go. This is a nice one. I like it. So clearly when you plug a 2 in, you get a half minus a half is 0 over 0. This is a problem. Whenever that happens, again, you should be able to do something with it. Now, at first blush, you're like, what do I do? Well, get a common denominator is the first thing I would do. So multiply this guy by 2, top and bottom. Multiply this guy by x, top and bottom. So I'm going to end up with 2 minus x over 2x over x minus 2. Now, at this point, a lot of times I'll put in over 1 because people freak out when they see a fraction divided by just one other binomial. So I just put it over 1, so now it looks like it's a fraction and then another fraction. Well, Mrs. So-and-so in the 5th grade always said, what do? Well, you invert and multiply, right? And you're like, oh, they're not the same. But you know they would be if you factor negative 1 out of that guy. Really, because what that really looks like, it looks like 5 and it looks like negative 5. Are you with me? I don't know, whatever. It doesn't really matter. These guys cancel, right? And what are you left with? Negative 1. It's the same thing. So these guys cancel, and you're left with negative 1 times 1 is negative 1 over 2x. Now, remember, that's not our answer. Our answer is what is the limit as x approaches 2? Well, it's negative 1/4. And again, should be able to show that that's true looking at it graphically to see if that's right. But again, don't want you to do them graphically. Want you to check yourself graphically because, oh, shoot. Because that is what a smart human would do. They would say, look, I've got this beautiful technology, and you're not to rely on the technology, but you're to use it to your advantage to see, does this look reasonable? So again, I'm interested at what happens here at x equals 2. Well, look at that. Negative 0.24, yeah. Negative 0.2, yeah. I could buy that was negative 1/4, couldn't you? I think I could. And remember, what we said was this is identical to it. See how that blue line completely covers the red line? Except it right there on the red one. Oops, because the red one's the one that's showing up on top, sorry. On the blue, God dang it, hide the red one. On the blue one, you'll see that what? The hole is filled in. Okay? They are identical except at x equals 2. And so all we're doing by this factoring and simplifications in algebra is we are eliminating the hole. We're eliminating it and making it a simple situation that I can actually solve. Okay? I'm going to do one more here. This one makes me fairly happy. This is one that we will do later on, sort of. We'll do it in a slightly different fashion. Oops. Oh, you idiot. I gotta think what I'm doing there. X plus A. Come on, Jay. What? 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 I wrote the problem down. Just a minute. Okay, so here's an example of one we will do later on. Because we will do this quite a bit later on. Because part of what we're going to do when we get to derivatives is going to be doing this same situation. Clearly, when you plug a and you get a squared minus a squared is 0. A minus a is 0. Crap. But the fact that it equals 0 means that x minus a is on the bottom already, but that means there has to be one of them on top too. That's how we ended up with 0 over 0. And then you're like, oh, that's a difference of squares. That's easy. Cancel, cancel. Now, what is the limit as x approaches a? Well, it's a plus a, which is 2a. Now, this problem will show up in a different fashion, and it will look like this later on. And you're going to be like, wait, what? Okay. And what's going to happen here is this. You're going to end up with on top, you're going to FOIL that out. So it's going to be, this is x plus h times x plus h. Okay. But what ends up happening is you let h go to 0. This becomes x squared over x squared, which is x squared minus x squared, which is 0, over 0, which is a problem. So if I distribute that out, I will get this over this. The x's will cancel. Well, J, they all have an h. Good, lose it. So you end up with 2x plus h. And what is the limit as h approaches 0? It's 2x. Notice how this looks very similar to that, because it's basically two ways of doing the same thing later on. But what we will be doing is a lot of this algebraic manipulation situations. And then we'll have either a situation where we'll have an x minus a in the denominator, and again that will end up also in the numerator, or we'll have an h in the denominator, and we'll have to get rid of it as well. Okay, because this guy is killing me, this guy is what's killing me when x approaches a, or when h approaches 0. And so I have to get rid of that. Okay, so that's the long and short of that section. It's pretty easy to do. It really just is a matter of factoring, multiplying by the conjugate, or adding or subtracting, getting a common denominator and adding or subtracting.